Today, ladies and gentlemen, we're going to talk about right triangles. This is our next unit that we will be covering. So, we're going to start off with the right triangle theorem. The right triangle theorem lets us know anytime we have a right triangle, we have two legs and a hypotenuse. The two legs are always connected to the right angle. So anytime you're looking for the legs of the triangle, you're looking for the right angle, and it usually has that red square in the corner. So we know in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So where we have the C, the hypotenuse is always the long side of the triangle. So what this phrase is telling us is that a squared plus b squared is equal to c squared. So the sum of the legs squared, a squared plus b squared, is equal to the longest side of the triangle, which is c squared. The right triangle theorem. Sometimes called Pythagorean's theorem, but that's a story for another time. But we refer to it as the right triangle theorem. So let's use the right triangle theorem. We want to solve for x. We have x on a leg, we have 8 on a leg, and 10 on the hypotenuse. We know that a squared plus b squared equals c squared because it is a right triangle. So we're going to plug in the values. So we know a is going to equal x, we know b is going to equal 8, and we know 10 will equal c. So now we have x squared plus 8 squared is equal to 10 squared. We can go ahead and simplify. So now we have x squared plus 64 is equal to 100. We can subtract 64 from both sides. And when we do that, we have x squared by itself. And we have x squared is equal to 36. Are we done? No. We're solving for x. We're not solving for x squared. So we need to take the square root of both sides. And 36 is a perfect square. So we get x is equal to 6. Good job, ladies and gentlemen. How about this one? I have 3 on one side, I have 5 on one side, and x on one side. What is the formula for the right triangle theorem? Yes, a squared plus b squared is equal to c squared. So what does a equal? A equals 3. What does b equal? B equals 5. What does c equal? C equals 6 because it's the hypotenuse. So we have 3 squared plus 5 squared is equal to x squared. We can simplify. So now we have 9 plus 25 is equal to x squared, which tells us 34 is equal to x squared. Are we done? No. We're solving for x and not x squared. We're going to take the square root of both sides. Now, 34. Are there any, we have to ask ourselves, are there any perfect squares in 34? Well, we know 34 is the same thing as 2 times 17. And 17 is a prime number, 2 is a prime number, so we can't break those down anymore. Okay, that would be our tree. So, since we can't, there are no perfect squares, we leave it alone. So we get the square root of 34 is equal to x. Excellent. So these are Pythagorean triples, also known as your ABC triples. So I know that 3 squared plus 4 squared is going to equal 5 squared. 6 squared plus 8 squared will equal 10 squared. And then all of these work that way. 5 squared plus 12 squared, it will equal 13 squared. Okay, these are called Pythagorean triples. So these all work for right triangles. So if we can work forwards, ladies and gentlemen, we can always work backwards. Exactly. So if the square of the length of the longest side of a triangle, which is the C, the hypotenuse, is equal to the sum of the squares of the length of the other two sides, then the triangle is a right triangle. Okay, so all that means is we're working backwards. So we can determine just by having sides of a triangle, is it a right triangle or not, if we have three different sides that we're trying to put together. So number one, if I have 4 square root of 3, and 8 are my three sides, and these are listed from smallest to largest. So that means that we know that a squared plus b squared is equal to c squared, but we don't know if these are equal. So let's make an equation and take the equal out. So we have 4 squared plus 4 square root of 3, quantity squared, and we want to know if it's equal to 8 squared. So we're going to square both sides, or we're going to square each term. So when we do that, we know 4 squared is equal to 16. When we have a outside number and an inside number, the square has to go to both. So the square goes to the 4, and the square goes to the square root. So now really we have 4 squared, which is the 16, and the square root of 3 squared. We know the square and the square root cancel each other out and just leave us with the 3. And 8 squared is equal to 64. We can continue to simplify. So 16 times 3 is 84. We know 16 plus 48, not 84, 48 is equal to 64. And since they are both equal, that tells us, yes, we do have a right triangle, because they did wind up being equal to each other. Number 2, same thing. We know that a squared plus b squared is equal to c squared. We're going to plug in the values. We know they're from smallest to largest. So we're asking ourselves, does 10 squared plus 11 squared, does that equal 14 squared? So we know 10 squared is equal to 100, 11 squared is equal to 121, and 14 squared is equal to 196. 100 plus 121 gives us 221. So we know that 221 and 196 are not equal to each other. Those are not equal to each other. So that tells us this is not a right triangle. Since they are not equal, this is not a right triangle. Let us keep going. So if it's not a right triangle, what could it be? So here, ladies and gentlemen, we have 3 scenarios that can happen for us. So we have a right triangle, and that happens if a squared plus b squared is equal to c squared. If a squared plus b squared is equal to c squared, that tells us we have a right triangle. Okay, it tells us we have a right triangle. If the c squared is smaller, that tells us we have an acute triangle. That tells us we have an acute triangle. If our c squared is bigger than a squared plus b squared, that tells us we have an obtuse triangle. We have an obtuse triangle. Okay? So if a squared plus b squared is equal to c squared, it is equal, it is a right triangle. If your a squared plus b squared is bigger Okay? If your a squared plus b squared is bigger, then it's acute triangle. And if your a squared plus b squared is smaller than your c squared, then it is an obtuse triangle. It will be an obtuse triangle. Okay. So let's take a look. Do these sides of a triangle form a right triangle, which would be equal, an acute triangle, which would be, so we're looking at, so we have a squared plus b squared and c squared. So if it's equal, it's right. If it's, if your c squared is bigger, you know it's going to be obtuse. And then if your c squared is smaller, then you know it's going to be acute. So let's go through these. So we know a squared plus b squared is equal to c squared, but we don't know if it's equal or not. So we have 4 squared plus 5 squared, and we're going to compare that to 8 squared. So we know 4 squared is 16, 5 squared is 25, and 8 squared is 64. 16 plus 25 gives us 41. So we're comparing 41, which is our a squared b squared, to 64, which was the c squared. So we know the c was bigger. The c was bigger. So what does that tell us? That tells us that we have to look at the scenario where it's obtuse. It's going to be obtuse. 64 is bigger, which tells us this is going to be an obtuse triangle. It's going to be an obtuse triangle. Number two. Again, we know that a squared plus b squared is equal to c squared. Again, we're going to plug in our values. So we're looking at 10 squared plus 11 squared, and we're comparing that to 14 squared. Well, we know 10 squared is 100, 11 squared is 121, and 14 squared was 196. So we know 221, and we're comparing 221 and 196. So that tells us that the 221 is bigger than the 196. So the a squared plus b squared is bigger. So that tells us that we are working with an acute triangle. We're working with an acute triangle. Excellent work, ladies and gentlemen.